funny way. We are in a new chapter with expert in history, Montserrat Guzman. What do you have to say about the Mendel's life, Montserrat?
Of modern genetics was born in 1822 in a German family that had a farm in a little town of the Austrian Empire, in which he worked like a gardener and a beekeeper during part of his life. He didn't finish his studies because his family was very humble, so he became a friar. In the monastery, he knew a man called Naf, who did permission to him to investigate the variation of the plants. He found very interesting the change of the plants, of the pea plants when was crossed few times. Also, he talked with some beekeepers about the Jan distortion hypothesis. He believed that with this hypothesis he can prove his story about the inheritance.
Thank you, Monte. Now go to the scientists. They will go to travel in the time to meet Mendel. Are you ready? Yes! Where are we?
Apparently, we are in the past.
Is he Mendel?
Who are you? Who are you?
We are your fans.
Hello, Mendel. It's a pleasure to meet you.
Me too.
What?
But what do you want me here?
It's because we hear about some of your experiments that you did in the past, and we are here to know how you did that.
Well, I will explain you, but we are going to go to this place.
Okay.
I want that you meet all this place because it's important to me, this area, because have all the things that I need to work in all my experiments.
So this is like your home.
Yeah, this is the best place in my life, and I want that you know who it's from.
So Mendel, can we make you some questions about your experiments and stuff like you did in the past, or with the bees and the plants?
Yes, I can. Don't worry about it.
Well, first, I was investigating about your experiments, and I found that in 1856, you started to study the inheritance of 7 different characteristics in bees. So, is that correct?
Yes, you are in the correct answer, but I focuses in 4 things like the age, the color of the flower, of some flowers, the color of the seed, and the shape of the seed.
So I heard that you laid the foundation of the science and of genetics, and based on this you discovered the basic principles of the hereditary.
Yes, I discovered a lot of things, and I don't know exactly when it happens, but I discovered it, and I like that in the future I will be recognized for this discovery.
Well, I know that the first law is called the law of regeneration, and this states that you have 2 copies of a gene and separate when an individual makes gametes. Is it correct? And how can you prove that?
Well, I explain it in my diary. I express all the things that I discovered. And the first thing that you say is correct, yes. If gametes receives only 1 copy, I will explain you how it functions and how it is related with all my results. And the most important thing of my experiments, obviously.
Well, I found you established lines of bees with 2 different characteristics, such as large versus low. So my second question is, what were your results in the experiment?
Well, in this case I found very similar pattern of inheritance. for the characteristics that I study. So it means that it will be repeated for some genes in specific.
Okay, so you have a second law that is very important. It's called the law of inheritance. You cross plants of traits. The two traits are involved in this process are called the hybrid cross, right?
Right.
Well, you cross the tall plants that had green spots with the breeding short plants that had yellow spots to produce F1 generation. How do you decide?
So when two unique factors responsible for a gene or characteristics are present in a single individual. So in this part, the most important thing is that the genes can affect in a future, not in the second generation. It will happen in around 2 or 3 generations more. One factor is the dominant, which is other recessive. So it means that while I have a dominant and a recessive, it will change with the time, with the future, because the combination will be different. As you see in this part, I can explain you better. In this part, you can see that the combination will be changed because we have another type of gametes.
Okay, so I see here that you have homozygous gametes with a recessive. This is from the first generation because you have here the parents, right?
Yes, in the first part, in the generation, we have 2 homozygous gametes. Then we have a combination of both. And then in the next cross in the second generation, we will have a combination of the combination. So it means it's difficult to assimilate at the beginning, but then you can understand how it functions and how the combination will affect in the future, because always will appear new shades, new color, and new ways to express the genes or the gametes that present as it.
Okay, for that reason we have more gametes here and here because it's a combination between the last generation, they combine and form new ones, right? And also this, I understood that the other ones are only a probability and more like this will be like this. So it's only a probability that can occur.
In this case, it's a probability, only probability, because it can change. As you can see, we have different options, and maybe in a future I will not have the 16 future generation. Maybe I will have 4, but all is probability. The combination can affect to have the same characteristic always, or to have different characteristics. So it means that with the future we will have different results in base of the probability.
Thank you. That's incredible. Amazing. Interesting. Okay, Mendel, but we have to go to our home.
Thank you for coming to here and talk with me about all the advances that I will have in my experiment.
Thank
and
you.
How the people recognize my experiment as something important in the world.
Thank you so much for your time. Bye, Mendel.
Goodbye.
My knowledge is science and gardening let me study the peas for two main reasons. One, it had in the market a wide variety of peas of different shapes and colors that could be easily identified and analyzed. The second one is that peas can self-pollinate. A single pea can give rise to other identicals to it, or cross by cross-pollination. Get to cross two pea plants at will, cross-pollination, or let them pollinate themselves. They were also cheap and easy to obtain. They took up little space, had a short generation time, and produced many descendants. I start my experiment by choosing two pea plants that differ in some characteristics. The type of seeds, like for example the color, if they are yellow or green, and another characteristic like the shape of the seed. And in another case is the color of some flower. In this way, it was possible to combine different varieties that showed phenotypic differences. As a result of crossing of plants with yellow and green seeds, produce plants that produce nothing more than yellow seeds, hereditary pattern that was repeated when crossing pea plants that differed in other characteristics. To the phenotype that appeared it called dominant, and the another one is recessive. In the first case, the yellow color was dominant, while the green color was recessive. In my opinion, the peas were a very suitable research material for the study I wanted to carry out. I designed my experiment very carefully. I collect a lot of data and I used mathematical analysis to show that the results obtained were consistent with their hypothesis, and in this case it will function with the probability. So, in general, with the study of this type of plants and the work with the pea plants helped me to understand how function the hereditary information, genetic information, in the future generations of the plants.
It was very interesting. The Mendel's life was very important for the science world. It's everything for today. See you later in another chapter of Science TV. Bye!